Okay, I'm doing a problem here with wave numbers. Wave numbers, as you know, have units of 1 over wave length. So 1 over meters are typically given in units of centimeters to the minus 1. So I'm going to take an example, 3,000 centimeters to the minus 1. And the question is going to be, what is the energy? I'm going to do this two ways. First, I'm going to calculate it with algebra, and for some of you this will be the easy way, some of you it will be the hard way. V bar, nu bar, excuse me, is 3,000 centimeters. So when I think about this, I try to figure out the equations I want to use, and units for this is going to be in kilojoules. I note that it's not kilojoules per mole, so I know I'm going to be using this equation. There's lots of ways to do the algebra on here. And I don't have the frequency, but I have nu bar. So I can get nu bar to give me the wavelength, and I can use the speed of light to give me the frequency. Doing the algebra, I'll start this way. E equal h nu. And I know that C equal lambda nu, so nu is equal to C over lambda, and I'm going to circle this and plug it in here so I can follow it, and it would be really nice if you did that. So I get E equal H C, and I'm going to do 1 over lambda so you'll be able to see the next step. Let me erase a little bit. So rewrite that HC times 1 over lambda. So now I look at this and I say, oh, look at that. Nu bar is equal to 1 over lambda. So I can just plug that in. So I can plug this in for here. So I get E equal HC nu bar. And now all I have to do is plug my numbers in. The energy equal, and I'm not going to have room for this, so I'm going to do some erasing. So now that I have my equation, I can say the energy over here is equal to 6.626 times 10 to the minus 34 joules seconds. That's Planck's constant H, times the speed of light, 3.00 times 10 to the 8th meters per second, times the nu bar, which is 3,000. I'm going to be real careful here, centimeters per on the bottom. I do it that way because I want to convert centimeters to meters. A common mistake is to say the 100 centimeters and a minus 1 is equal to 1 meter to the minus 1, and that's absolutely not true. Okay, so you don't want to be doing that. It's centimeters to meters. So I got to multiply by 1 meter on the bottom and 100 centimeters on the top. Thus my centimeter units will cancel, my seconds cancel, my meters cancel, and I get my answer, which is, whoops, I forgot one thing. I forgot my kilojoules, so let me erase that. Put my kilojoule to joule, 1,000 joules, 1 kilojoule, and I get, if I did my math right, 5.96 times 10 to the minus 23rd joules. There's an example of V bar. For some of you that will be easier. I did all the algebra first. Another way of doing it is to do each step. Calculate lambda from here, then calculate frequency, then plug in here and do it. So you'd have 3 steps showing algebra for 3 different problems. You have to spell all that out if you do it that way. Either way is sufficient. Okay? So there you go, example with nu bar.